Okay, super. Okay. Mm, ஒரே நிமிஷம் மேடம். மீட்டிங் ப்ராப்பர் ஆகிட்டு ஓகே தெளிவாயிடுச்சு. ஓகே. Again, good morning to Arjun, Anbazhagan, and Nithish. We are going to discuss on the second topic on more on the Josephus problem in a data structures and algorithm course perspective. So, in previous course of course with session with Arjun and Anbazhagan, I have explained about the mathematical terms where the k is the number is fixed or just just adjacent person is still. But now we are going to for a more defined algorithmic way where any adjacent person or the more different person is skilled also we can find a solution. That is a more user input customized solution. We are going to find it out. So thanks Nitish for joining us in this Nitish sir for joining us in this session. So we will look onto the customized generalized solution for Josephus problem in this one. So yeah, let's get into the problem. Okay, I will share the screen also. Screen as well. So not doing it. Yes, it's for me. Yes. Yeah. Oh, I hope the screen is visible and clear. Yeah, visible.
Yeah, it's just,
Okay. So previously we have seen when in a Roman problem where Jews are killing themselves in adjacent manner one by one. So in that case, we have formulated the solution for uh, formulated the solution in a mathematical set like data set approach point of view, and then find the solution as 2l plus 1 using some mathematics. That is very well done, but we are not going to look into this mathematical aspect of it. So we will just first read the question and then we'll see how it goes. The solution is like we have taken the k as a fixed, but now the k is different. So I will read the question and I will explain what is the question is. Given the total number of persons n and a number k, which indicates that k minus 1 persons are skipped and kth person is killed in a circle in a fixed direction, which means given a a total number of persons n. So let's suppose the n is fixed 1, 2, 3, 4, 5, tick n, and the number k, which means they are giving a input in a function. They are giving just int n and a int k. It is not much of like you can just assume the input to be of n and k. I am writing in a computer function that system function that doesn't need to be much. The pseudo code is pretty much enough. So the input is n and k. What they mean is n soldiers are standing, n persons are standing, and k, the number k, which indicates that k minus 1 persons are skipped and kth person is killed. Which means, let's suppose k is 3, which means k minus 1 is 2. K minus 1 is equal to 2. Two persons are skipped and the third person is killed. So two persons are skipped in the sense 1 and 2 is skipped and third is killed. 4, 4 and 5 is skipped, 6 is killed. So there is two gaps in this new scenario where k is equal to 3. In our previous scenario, if you have seen, there is only one gap. Like only one person is left. That everything like it goes on a circular way. So now the k is changed. But even they can give k is equal to 4 or k is equal to 5 and can find us and can ask us to find the solution for that case. So we want to generalize an approach, and then we want to generalize using any approach, and then uh, we'll write a function defined for this in a pseudocode manner, like in a easily understandable logical manner, and then we will uh, get the outputs. Like let's suppose n is equal to 3, k is equal to the output that are okay. We will solve this input as such, and we'll give more clarity for you. N is equal to 3 and k is equal to 2. 1, 2, 3. K is equal to 2 means k minus 1 is equal to 1. I have said skip k minus 1 persons in the question. K minus 1 persons are skipped. So k minus 1 is 1, so 1 person is skipped. So 1, if 1 is having the square, so like it basically means 1 is skipped, and like in our case the sword logic is different, this logic is different because you have to see from the outer perspective of k. In that case the next person is killed, that is different. In this case 1 is skipped and 2 is killed, like it should be taken in that case like 2 is killed. So killed means I will put like this, and then 3 is skipped, 1 is killed, so 3 is the solution. So output is 3, they are meaning that. So that case, that k number don't want to take it into account because we are not seeing in the perspective of a soldier. Now we are seeing in the perspective in the overall in the like you are seeing it in the computer like think like that. You are skipping one and removing two. You are skipping three and removing one. In that case, you want to move now rather than thinking that one is killing two, two is killing three is killing four. Not like that. So that this idea of skipping two, skipping three will make a more clearer idea on what we are going to do in this problem. So this also goes in the same way. What we are going to do is we'll find solutions for a smaller set of problems and we'll make it applied for the larger set, any set, using recursion. We'll see what recursion and what the idea is in a pretty much few minutes. So yeah, the task is to switch in the safe place in a circle so that you perform these operations. Starting from first place in the circle, you the last one remaining and survive. It is basically the same Josephus problem. We want to escape from killing. They made it in the different way. That's it. Yeah. They also said the same thing. That there are three persons, so skipping one person, that is first person, second person will be killed. Thus, the safe person is three. Explanation is not needed. We will get on to the solution part. I will explain the that part here. This algorithmic way for killing next person is done. If just k is equal to for two k's, we can define just write the equations for that algorithm and get the answer. But that is not our whole point. When we have a better approach, so we'll just find the answer for any k. So we will just do the same thing and we'll try to get answers one by one. So yeah, I hope things are clear. So I'll draw a line. Okay. Wait a minute. I'll punch it. Okay. Yeah, now it's in. So thing is, uh, yeah, it's fine. Now we are going to draw for 1, 2, 3, 4. Let's keep it simple. 1, 2, 3, 4, 5. We'll start with that. Now our approach is different. Previously the approach was different. In like we want to say write a code for machine to solve. Previously we write a code for any mathematicians to solve or many mathematicians to understand. Now the machine should learn and understand. So we will write for that purpose. So we'll write 1, 2, 3, 4, 5. So the answer, let's suppose uh, for a question, if you see the k value is fixed, what they will give is function of n comma k. K is fixed in a question. In a question, for same k they can give different n. For different n they can uh, like different n they can give different k also. That both are independent of each other. But what happens, we'll look one by one. Like I'll just explain that. Comes on like that comes easy while explaining. Give it rather than giving the overall idea. So let's suppose a simple case of n is equal to 2 and n is equal to k is equal to 2 and k is equal to 3. So for k is equal to 2, the solution is very simple. We will skip 1, skip 1 comma 2, skip 1 and 2. So we'll skip 1 in the sense we will skip 1 and then we'll kill 2. We'll skip 3 and we'll kill 4. We'll skip 5 and we'll kill 1. Skip 3 and we'll kill 5. So the solution is 3. We'll check it out with the above one. Is the solution same or not for 5? The solution is 5, third is the safest location. So we'll write it as for a function of 5, n is equal to 5 and 2, I mean k is equal to 2, the answer is 3. For function of 5 comma 3, we'll check what is the answer. 1, 2, 3, 4, 5. So now we will skip 2 people because k is equal to 3, so you want to skip 2 people. So 1, 2 will be skipped, 3 will be killed, 4, 5 is skipped, 1 is killed, 2, 4 is skipped, 5 is killed. So now it is even more careful. We want to skip two things and there are only two people and starting from two. Two is skipped, four is skipped, two is killed. Because two and four is skipped and then again it came to two and two is skipped. So four is the solution right now. Okay. Is that understandable? So the answer changes for different n value. So what you can look at is uh, uh, am I audible? These things are
Yeah,
clear.
yeah, yeah, audible.
Things are clear right now. This okay. Let me take a break for a second and then I'll give it an overview idea. Hmm, okay. As 1 minute break is needed now. Yeah. Let's continue. Think this. Uh, I want to say you think about recursion. What recursion is? Recursion. I'm just making it bold so that this is the most important thing which I'm going to do. So what recursion is? Does anyone of you have idea on what recursion is? Recursion is a mathematical like it is not a mathematical. It is a concept in computer science. Like a function repetitive calling. So I'll just say what recursion is. Recursion basically means that you are doing a thing repetitively, a function repetitively until a condition is satisfied, until a condition is not met, or whichever thing is. So what you will do in recursion is the very best example for recursion was factorial problems. If you see 5 factorial is 5 into 4 into 3 into 2, 1, or which is 5 into 4 factorial, right? So what is 4 factorial? 4 factorial is 4 into 3 factorial. 3 factorial is 3 into 2 factorial. So what we will do is we will just define 1 factorial to the computer that 1 factorial is 1 and we'll say 2 factorial as 2 into 1 factorial. 3 factorial as 3 into 2 factorial. So what it will do actually is n factorial as n into n minus 1 factorial. Okay. So what the computer does is basically whenever you need something, it will like function of factorial of n you will put and then you will type return, which means uh, return the answer as n star n minus uh, factorial of n minus 1. So what it will do is it will multiply n into factorial of n minus 1. Basically, that will again call this function with integer n minus 1. So what it will do is n will n will call n minus 1 and then n minus will call n minus 2 and n minus 2 will call n minus 3. It will go on until some 1 is reached. So one value it knows, so it will calculate the previous thing, it will calculate the previous thing, it will calculate the previous thing, and we will get n factorial. So this is how it goes, okay? So basically, if you know the solution for a smaller thing, you can find a solution for a larger thing. Is what recursion, the whole idea of recursion is. Okay, that is what the recursion is basically comprised of. So my video is that. Okay. So that is the idea of recursion. So what we are going to do with that recursion, the Josephus problem is we are going to define the solutions for smaller problems and then find a relation. For now, you know that n into n minus 1 factorial, but in Josephus problem, you don't know the how to do that. So in Josephus problem, you will find that relation now, and then you will put that relation in the small pseudocode function, and then we'll get our answer. Okay, it's that clear?
Yeah, clear.
Yes, clear. Right? Any doubts on what where are we going or Anbalagan, do you have any doubts?
No doubt, Arjun.
Super. Okay, that's pretty much. We'll start with the recursion thing. Basically, recursion thing we want to find relations between n and n minus 1, the n and the previous thing. So now we'll do the basic thing 5 and 4. We'll keep the so we can keep the k fixed in this and then we'll find the relation with n and n minus 1. So let's keep k is equal to 2 for simple purpose and try finding relation between n and n minus 1 between n and n minus 1 or 5 and 4 minus. 5 minus 1, which is 4. So for 5, what we will get is, we'll draw like this. Why does, okay, not an issue. 1, 2, 3, 4, 5. So the solution goes like 2 cut, 4 cut, uh, and then 1 cut, 3, 5 cut. So 3 is the solution. This is the solution. For another thing, 4, 1, 2, 3, 4. So 2 cut, 4 cut, 3 cut. So this is the solution. Uh, so you want to figure out, like, create a pattern in which you can. Okay, I will create another pattern. So 4 is done. So I'll create for 3 also. 3 as well. 1, 2, 3. So now 2 cut, 3 is left, 1 is also cut. So yeah, 3 is remaining now. That's all right. 1, 2, 3. 1, 2 is cut, 3 is cutting 1, so 3 is remaining. So what you can try to do is, you can put all these on all these answers on a, what you can say, mm, yeah, all these answers in such a way that it gets a relation to the numbers. I will like try to figure it out with you that. In this thing, if you have seen, for 4 the answer is lies in here, like the 1 is the answer. For 3, the like for 3 n is equal to 3, the 3 is the answer. So what you will try to make down from this is, uh, we'll try to we'll try to change the order of the number so that it matches with the solution. Like let's repeat, rotate like this. What we'll do is, let's rotate this. So 3, if the 3 comes here, it will match exactly where the 1 is there. 1 is that, and then 2, and then 3, you can put it here, 3, and then 4. Now 3, if it goes there, it goes like 2, 1, 5, and then 4. So we will catch up this order alone. Like, as it is only 4 here, for that we will catch up this order. Okay. And then we will write for a new thing. We will write in relation that the position, if the position of, like, this position is the answer. So 3, the position of 3 and 1 is linked. If 1 is changed to 3, the solution you will get, like, you will get the solution. So we will get to change the numbers exactly from n minus 1 to n. The entire numbers will be changed. Basically, like 1 plus 2, 2 plus 4, 3 plus 5. I will write it down and show. So 3 is changed to 1, 4 to 2, 5 to 3, 1 to 4, I guess. Yeah, 1 to 4. Basically, what happens is, if 3 is changed to 1, like minus 2 is done, the another sequence of 4 is created. Like this is for, I will write that as well. N is equal to 5. This is for n is equal to 4. Here also this is solution. So that solution thing you don't want to think much. If this n is equal to 5 sequence is changed, the numbers of the n is equal to 5 sequence is changed by reduction of 2. Like 3 is changed to 1, and 4 is changed to 2, 5 is changed to 3, and 1 is changed to 2. This alone we will look at later. If the numbers is changed in this way, we will get the same pattern as n is equal to 5, and the solution can be repeated. Here's some, okay. So what I want to say from this is, there is some pattern in this. So if you look lower on, like from 4 we can find 5. You can just make this arrow reverse as well. Okay, this thing doesn't matter. So from 4 you can find 5. So if you just add plus 2 and then make a thing, from 4 you can find a 5, and 5 you can find 6, and 6 you can find 7. So I'll just repeat the things again. Like this logic and all, we want to figure it out. So I will repeat the same thing for Anbazhagan. From this thing, what you can find is, if n is equal to 4 you can add something or can do some mathematical operation like modulo or something, and can find the solution for 5. You have 1, 2, 3, 4 in n is equal to 4. And from that, you can make plus 2, plus 2, plus 2, and we'll get the same sequence in a different way. And that you can find n is equal to 5. From n is equal to 5, you can find n is equal to 6, and n is equal to 6, you have different thing. So we have to figure out that thing. So what is that? What is done from n is equal to 4 to n is equal to 5 is what we are going to figure it out. So if you can see it clearly say that only can say that okay I will take this one. Okay, this one is completed. Okay. Plus two okay. That's okay. Uh, only plus two is added, plus two is added and all, and then it is converted. But that is wrong because if you add 4 plus 2, it will give to 6, but 6 is not there. So what it is done there? Can anyone say why instead of 6, 1 is written there? The logic of plus 2 may be correct, but that doesn't apply when fourth people plus 2 gives sixth people, but n is equal to 5, you can't put 6, so they have written 1. Like how they did that? What is the mathematical operation which you can try to use?
The sixth person will be since they're not six people, sixth person will be like maximum you can go till five and then
Uh,
one.
yeah, it
Like
is basically like a repetition in a circular fashion, right? Anbazhagan, can you say some mathematical functions to do that repetition of 6 as back to 1, like in a circle of only 5? So what it is basically is making a circle of only 5. 1, 2. If the 4 wants to move 2 times, 4, 5, 6, 4 wants to move 2 times. Instead of 6, it wants to go to back to 1. So it is like a circle of just 5 numbers. It is not, it cannot exceed that. Is there any mathematical operations to do that? You have to operate on 6 and make it 1. Is there anything I think of it?
Anna,
Say, say.
okay now.
Like any mathematical operations, can you think to make 6 as 1 or 7 as 3, like that? Okay, I will give a hint. So what you can do is you can take 6 modulo 5. Modulo. Modulo means remainder. Remainder is something which will give the answer only in the range of 1 to 5. Yeah, remainder cannot go above 5, right? Or else it will go, if it goes above 5, that number can be get into the 1 for the question. So 6 modulo 5 is 1, 7 modulo 5 is 2. Is that clear? So what happened here is you are adding plus 2. That plus 2 makes it as 6, but that number is modulo with the 5. 5 is nothing but the n. So what you are doing is you are making the number the number is nothing but f of n minus 1 of k. You are adding it plus 2, and then that number is made modulo 2. Modulo not modulo 5, that number is modulo n. So that you will get f of n of k. Is that understandable? Basically, every number function means every number, right? You have seen functions as basically as a mapping. So every number in f of n of k is basically created by this approach. Like basically using a plus 2 and then a modulo. Let's suppose you try for this. A number of 1 in this. Number of 1 in n is equal to 4. F of n is equal to 4. 1 is 1 plus 2 modulo 5, which is equal to 3. Right? So that is the same. Modulo 5 will give you sales like the same thing. I don't want to write this more. It's too much complicated because the equation is more important. Not to make them messy. So, n is equal to like this 1 plus 2 modulo 5 if you put, or modulo n. The n is this one. We are finding n through n minus 1. So that is the idea, right? Idea for recursion. So that is the idea for recursion. So we are taking modulo by n. Why we are putting it n is we want, if the n is changed, like we cannot write it as 5 because if the n is changed, we want to change the modulo operation accordingly. So we are putting it as modulo n. Okay, is that clear up to now? Is that clear?
Clear, Anna.
Okay. In our case, if you have seen, it is 2 k as 2, right? So that it works. But for a generalized case, we want to think on that as well. So what we will think on that is, so basically f of n of k is equal to f of n minus 1 of k. You'll write that as first, and then plus this 2 is also changing as per k. How it changes, let's look at that. We can take another example and look at that, but we'll just try to identify with this as well. What you can look at is, yeah, what you can try to look at is, it is plus 2. So plus 2 is basically, in our case, it is a k. You cannot just write this as k because there is a problem with that. I will let you know. Like, let's suppose, let's take the case of, hmm, uh, what you can take. Just a minute, I will say this one. Like 6 plus 2 modulo 5 will give you 8 by modulo 5, which is 3. And 6 plus 1, like, I mean, 7 by modulo 5 or 9 by modulo 5 plus 1, like, or plus 2. That will give your answer as 4 plus 1, 5. So basically, uh, basically what you can try to do is, okay, Orange, I will just think on this as well. Because I have a small confusion. We can just write k here, but I'm just thinking on whether to write k or k minus 1. Whether the modulo operation inside and outside will change as such. Because if you're adding and taking a modulo, like what I am thinking is whether to write it as k minus 1 plus 1 and this plus 1 out of modulo, or just this as k and after taking it as a whole modulo. I want you to think as well whether writing it as k minus 1 and then 1 outside the modulo. Because 1 outside the modulo will make the value always plus 1 in default. If, yeah, that is 1 outside the modulo will make the value always 1 in the default, even if it is divided by the modulo. So much things to say in this one. So there's some problem with modulo. What is 5 modulo 5? Modulo means remainder, right? What is 5 modulo 5?
0.
0. So let's suppose if this number comes as n. In some cases for 7 and all, if you've seen, the solution is 7 itself, right? Let's suppose if it number comes as n modulo n comes as 0, which we don't want. Rather than we want the solution as 1. Is that right? Is that correct? Like instead of, like, what I'm meaning is, if the number comes as 5, the number can be 5. Like the number can move on and can go for 6, not like just sitting at a 0. Basically in computer, like the remainder goes in 0 rather than we want the remainder get started at 1. Like, I can say it even more clearly. Like, let's suppose, uh, let's take this case. There is only 5 numbers. The problem is 0 shouldn't be coming, but modulo operator provides 0, so that we are going to make it plus 1. I will say through this one. Uh, okay, okay. Keep it, okay. Wait a minute. You can take the example like this. Uh, in some case of example where example itself can be more generalized rather than providing for the case where there is an addition and then you are getting a 0, because modulo operation can provide 0, but you don't want 0 in the output because we are writing it only with a soldiers like n numbers. So what you will basically do is you will always have plus 1 on the side when the entire thing is getting divided by 0. So what you will do is, instead of, okay, instead of, okay, what I will do is, just write k and then divided modulo n, The answer can be 0. Can be, because the screen is not that much good, can be 0 at sometimes. But we need 1 at that case. But that is not possible. But n can't be 0. N can't be 0. N cannot be 0. So what we will do is, we'll do a small thing. Just a small thing. What it is? F of n minus 1 k plus k minus 1, and then modulo n, the larger operation, you will do modulo with that, and then you will add plus 1. That is the equation that we are going to deal with. Is that clear? Like, this is how the mathematics works. Like, when you change it from one to another. When you are using a modulo operation, you will get 0. So you want to encounter that. We'll add plus 1 later and then subtract while taking before taking the modulo. Actually, it is a difficult interview questions asked in many like Oracle, Amazon, Microsoft. So they will check every point of view on how you think and how the solution is. You have to think in practical cases as well, not just by writing K there. So this is wrong. This is the reason this is wrong. So wrong because produces 0. Is that clear? Is that clear?
Yeah.
Okay, okay.
Clear and
Is that clear? Okay, then what we can do is we can just pause it down. Okay. Now, if you have seen the equation, we have written f of nk is equal to f of n minus 1 k of k plus k minus 1 mod. I have explained this. Equation is wrong because it produces 0. Which means like 0 is included in the 1, 2, 3, 4, 5. But they said it starts from 1. So, as per the question, we are not using this equation. So, we are shifting to this equation of k is equal to f of n minus 1k. Basically, what it does is this equation asks for the solution from the f of n minus 1k equation, and in that solution, okay, my audio is clear. In that solution, it will do. Is my audio clear?
clear, Anna.
In that solution,
Clear.
it will add k minus one, which is the steps skip, like the present skip. Will add that skipped for pills, and then we'll do modulo. Sometimes modulo happens, or the same answer will be repeated of these two, and then plus one is added, so that you will get the solution for f of n. So using n minus one, you will get the solution for n. So for like, but n minus 1 gets a solution from n minus 2, and n minus 2 gets a solution from n minus 3. It goes on until the number reaches 1. Because we know the solution for f of 1 of k as equal to 1. When there is only 1, whatever the skip you do, the solution is just 1. So we will go until this recursion. This thing will go until that and will make it as 1. So that is how the solution works. So let's do a basic thing, and then we'll check how this recursion gets the answer for this. So let's put f of 1 of 3 of k, that will give us f of 2 of k, and k can be set as 2. So 2 comma 2 plus k minus 1 is 2 minus 1 1. Modulo n is 3, right? So plus 1. So what it gives is the solution for 2k we don't know. So we'll find from f of 2k, we will find from this one. Again, the older equation where f of 1k will use that, and then plus 1 modulo 2 plus 1. So for this, you will get the answer for f of 2 comma 2. The answer is 1 is answer is 1. 1 plus 1 2. 2 modulo 2 is 0. 0 plus 1 1. So for that, so you'll know now the answer is. So I'll change the pen color alone. The pen color. The pen color I will have this one. So through this, you have find the answer for f of 2 comma 2. This 2 comma 2 will put it on 3 comma 2, the older equation, and will 1 plus 1 modulo 3 is 2 is the answer. So 2 plus 1, 3 is the answer. So now you know that f of 3 comma 2, the answer is 3 given by the equation which we found out, which is actually correct as verified previously. So if you've seen here, the 3 also, the answer is 3 only for k is equal to 2. So our equation is correct. You can identify through this. Like, I just substitute k because we know the values of k previously. And just by substituting f of 1 of k in the predefined previous equation, we understand that the recursion works, this problem works smoothly and find the answer. So this is how it works. So what we will do further on this is, we'll just write a code for this. The code is, code is basically if n is equal to 1, this is right, you don't want to see that much. If n is equal to 1, return 1 and else. Or if in the different case, what you'll do is, just have, can write else in this case, but you don't need always. Like if you are putting it on a larger function, you don't need else. Like you can just define the function in Josephus. I will just clear that. N equal to 1 return. In other case, what you will do is, if the if statement doesn't go, if n doesn't go into n, what you will return is return f of n minus 1, like the function of n minus 1 k plus k plus k minus 1, the whole modulo, this whole light moment. I'm just writing the above equation. Whole modulo n plus 1 is the written thing which we are going to do. So this will be written. So you can add another bracket as well, not a big issue for plus 1. So this is how it goes. This everything is inside a function. Inside a function of int Josephus or whatever you call it. That is the pretty much C++ code for this. Like a public class is defined, class solution. If in this class what will happen is the int n, this will get the two functions as input, and then if n is equal to 1, it will just basically return 1. If n is different number, it will get n minus 1. It will call n minus 1. So n minus 1 will be called back to here, and then it will check if n is equal to 1, else n minus 2 will be called, and it will go on until n is equal to 1 is reached, and then n is equal to 1 will be substituted in the back equation, and then after getting n is equal to 1, the equation will get back multiplied, and it will reach up to the end point. Like 5 means it will take the value of 4, 3, 2, 1, and then we will do the calculation and we will give the answer. I hope the solution is clear. This is a small solution. It may look very small in the C++ code, but actually it can solve for any n and any k. Okay. I hope this creates a lot of curiosity for Anbazhagan and Arjun in this meet. If there is any doubts, you can reach me anytime. Yeah. Any doubts or any idea on how this data structures, how this algorithms work, how this aptitude this works? Are there any suggestions? Is the solution clear? It may be a bit difficult to understand the last part, but if you try repetitively on your own by solving the question, the same question again 2, 3 times, you will get to know it exactly in an easy way. I think a lot of time has been given explanation. I hope it makes it clear. Any doubts, Anbalagan?
No, Anna.
Arjun?
Yeah, no.
Yeah. Basically, Anbalagan is a 12th computer student and Arjun is a BTech mechanical engineering student. So my DSC assignment has been done successfully with your help. Thank you for your Bye.
Thank you, Anna.
I can leave the meeting.
Thank you.
I will end the meeting. Thank you.